So in the first lesson we did factorizing by finding a common factor. You always start factorizing by looking for the common factor. Once there's no common factor, if you're still factorizing, we can factorize using a difference of squares. And that's going to look like this. We look for perfect squares. Those perfect squares are these numbers here. These are called perfect squares because 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9. So that gives us our perfect squares, and you should learn your perfect squares, the first 15 perfect squares, so that you can easily identify them. So if we review what we've already done in multiplying, if I took this and I multiplied x minus 2 and x plus 2, using FOIL, first term, x times x gives me x squared. Look what happens with middle terms. The outer goes x times 2 is 2x, and negative 2 here, negative 2 times x gives me negative 2x. So what happens there is those two will cancel each other out. And the last one, negative times a negative is negative times a positive, sorry. Negative 2 times positive 2 gives me negative 4. And so I land up with x squared minus 4, and that's called a difference of squares. So what's involved in looking for a difference of squares is this. You look for, are there only two terms? Is the first term a perfect square, and is the last term a perfect square? And is there subtraction separating these? If the two terms are both perfect squares, separated by a subtraction sign, then you can factor by using a difference of squares. Look at this example, x squared minus 25. Well, x squared is a perfect square. 25 is a perfect square because 5 times 5 is 25, and they are separated by a negative sign. Well, let's do that. In my brackets, I'm going to have two brackets here. An x squared means this bracket's going to have an x, and this bracket's going to have an x. The square root of 25 gives me 5, so that's going to have a 5, and that's going to have a 5. Now all that's left to do is just get the signs. And in the difference of squares, one bracket's going to be negative, the other bracket's going to be positive. And that's factorizing using a difference of squares. If I went and did a check here, using FOIL, first gives me x squared, outer gives me 5x, inner gives me negative 5x, and last, negative times positive is negative 25. And what happens here? Those two cancel each other out. I'm left with x squared minus 25, which was the question we started with. So this here is factorizing this question using a difference of squares. Let's try another one. 16x squared minus 9. Two terms separated by a negative sign, where this is a perfect square and that is a perfect square. So I'm going to have two brackets. Let's draw our two brackets in. Find the square root of this term here. Well, 16, the square root is 4, and of x squared is 4x. So both are going to have a 4x in. Find the square root here. Square root of 9 is 3. And both are going to have a 3. Remember, one's going to be negative, the other's going to be positive. There we go. We factorized using a difference of squares. We can go back and do a check for this one. First term, 16x squared. Outer is going to give me positive 12x. Inner is going to give me negative 12x. And last is going to give me negative 9. Again, positive 12x, negative 12x cancel. I'm left with 16x squared minus 9. I've factorized using a difference of squares. One last one. The whole term has to be, you find the square root of the whole term. I've got two terms separated by a negative sign, where both are perfect squares. The square root, so let's actually start with our brackets again. Square root of 81 is 9, and the square root of a squared is a, so both are going to have a 9a. Square root of 49 is 7, and the square root of b squared is b. So both are going to have a 7b. Finish off by going one's positive, one's negative, and really it doesn't matter if you make the first one negative or the first one positive, and those can be in any order. There we go, we squared rooted it. If you don't believe me, go and do a check. First, outer, inner, last. Go and do your check. You'll come back to this question. Easy. So difference of two squares. We've got perfect squares. Both are perfect squares. Both terms. There must only be two terms. And remember, it's a difference, meaning they're separated by a negative sign. Go and check for that, and you can factorize using difference of squares. Right, hope that helped.